Hello and welcome to our demo of BotSync, a search-based crash reproduction framework for Java. BotSync gets an application and a stack trace which has been thrown in this application as input. And the output of this tool is a test case that if we execute, it will throw the same exception as the given one. The central part of BotSync for accomplishing this task is the test case generation. In this part, BotSync starts a single or multi-objective evolutionary search. During the search process, BotSync generates random test cases and tries to find a test which reproduces the given crash. This search process is guided by one of the implemented fitness functions in BotSync. These fitness functions measure the distance of the generated test from the scenario that software under test throws the given stack trace. This search will continue until either the time budget of the search process is consumed or BotSync finds a crash reproducing test case.
BotSync has another module called seeding. With seeding, BotSync uses the existing knowledge about the software to improve the test case generation. To enable seeding, we need to provide either the existing test cases or the models learned from the software.
Let's see how BotSync works in action. Here I have the jar files of the latest version of BotSync, plus that I have the required inputs for BotSync for reproducing a crash. In this example, we have Apogee Commons Lang as our application. In this directory, I have the jar files of the Apogee Commons Lang and its dependencies. Plus that I have a stack trace for this application. This stack trace is array index out of bound exception and it contains 10 frames. To reproduce this crash, I just need to call BotSync reproduction jar file with proper inputs. The first input is the project class path, which is the directory of the compiled version of Apogee Commons Lang. The second input parameter is the directory to the stack trace log. The third one is the target frame. Here I set it to 5. It means that I want to reproduce only first 5 frames of the given stack trace. The other input parameter is the search budget, which is here it's 180 seconds. And the last input parameter is the output directory. If I run this command, BotSync starts to reproduce the crash. As we can see here, BotSync managed to reproduce this crash, the first 5 frames of this crash, only in 4 seconds. For executing the generated test, we need the class path of software under test. Also, we need EvoSuite standalone runtime jar file. The reason that we need this library is that BotSync uses EvoSuite test generation for generating the tests during the search process. When we run this test, we can see that it can reproduce the first 5 frames of the given stack trace, as we expected. If we try to reproduce all of the 10 frames of this stack trace, in this case, BotSync could not reproduce the crash because it consumed all of the time, but the fitness function is still free. If BotSync can reproduce a crash, the fitness function will be 0. Now let's try this execution again, but this time we will use the behavioral model seeding as well. As we explained, model seeding needs the usage models of the classes in the software under test. For generating those models, we need to run BotSync model generation. This tool needs 3 inputs. The first one is the application or the software under test, which here it's Commons Lang. The second one is the prefix of the class paths that we want to apply the static and dynamic analysis on them for generating the models, and the last one is output. After finishing the execution of the model generator, if we check the directory, we can see that now we have another directory called model lang. Here we have a directory called models which contains lots of XML files. Each of these XML files is a transition system which represents the usage of one of the classes. Now that we have the generated usage models, we can run BotSync with model seeding. For adding model seeding to BotSync, we need to add 2 new input parameters. The first one is the directory that we saved our models in it. The second one is the probability of using the objects which are derived from the given models. Let's start the execution. Thanks to model seeding, this time BotSync managed to reproduce this crash. We have the fitness function 0 and it took about 84 seconds. If we run the generated test, we can see that it reproduces all of the 10 frames of the given stack trace.
Thank you for watching the BotSync demo video. This tool is available as an open source tool in GitHub. You can also visit Buzzing website for more information.